Hello and welcome to Unit 2, Probability. So in this unit we are going to use the skills we learned in the first unit and we are going to apply them to the concept of probability. Before we get into probability today, we're going to be looking at the topic binomial theorem, and the learning goals that we have today together is by the end of not only the lesson but also your homework, I can explain and apply the binomial theorem to algebraic expressions. So this is kind of the only algebra lesson for the entire year in this course. So let's get going with that then. So the first thing I want to talk about are properties of Pascal's triangle. So Pascal's triangle, you set it up, or you've already talked about it in the first unit, and in this one we talked about how you develop each of the stages here. So 1 plus 1 gives us the 2, 1 plus 2 gives us 3, 3 plus 3 is 6, and so on and so forth. 6 and 4 is 10. There's a couple other properties that I wanted you to be aware of before we move on. So I'm just going to come over here. And first thing I'm going to put up here is our row number. And remember, Pascal's triangle starts with row 0, and then 1, 2, 3, 4, 5, and 6. The next column I'm going to put in here is the sum of row. So the sum of the row is just adding up what the values are in that row. So for row 0, there's only a 1, so it would be a row total of 1. Row 2, 1 plus 1 is 2. The next one, 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1 is 8. And just speeding up the process here, we would have 16, 32, and 64. And if in doubt, you can always check that with a calculator. What I want you to notice is the pattern between the sum of the row and the row number. So if you look down that sum of row that I've just put up there, 1, 2, 4, 8, 16, 32, 64, you can see that they're basically what's happening is that we're doubling each time. So we're doubling. So we can come up with a formula to give us the value of the sum of each row. And because we're doubling, the common base is 2. So if we write 2 all the way down, and we try to find an exponent that will give us that answer. So in the second row there, row 1, if we look at this one here, we know that we're looking at row 1. The sum of the row is 2. So if I go 2 to the exponent 1, it would give us a value of 2. To get the 4, you would go 2 squared. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6th is 64. Going backwards at the top here, 2 to the exponent 0, anything to the exponent 0 is 1. So my summary here, sum of a row is 2, and that exponent comes from the row number. So you can find the sum of the 53rd row in Pascal's triangle, the 108th, it's just 2 to that row number, and that gives you the sum. So kind of neat, and it's kind of a question that may come up in the homework, so I thought I'd go over that. To the next one, combination notation. So you already dealt with combinations, and technically there are 4 forms, and really to this point in your notes you'll only have 3, and the 3 that you're familiar with would be in the form NCR as one of the notations, and that's the same as permutations, which is the same as saying combination NR. All right, and it doesn't matter which notation you use, both are acceptable in this case. The third one that you're aware of is your factorial notation. So you end up with the factorial notation, which will be on your formula sheet, that form there. Now, the 4th form that you're going to see in this unit a little bit more is what we call kind of a matrix notation. And permutations don't have this notation, so this is only for combinations. Okay, so only for combinations. And I'll show you the reason for it. So it's only for combinations. It comes from Pascal's triangle, and I'll explain why, and you can check with your calculator in a minute. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That's lots. So what I'm going to do here, I'm just going to show you the combination format for Pascal's triangle. So each part of Pascal's triangle can be written as a combination, where the first one, for example, on the top of Pascal's triangle would be 0, 0. So if you punch 0, 0 into the calculator, you would find you'd have 1. For the row number 1, for row number 1, right here, you would have 1, choose 0, and 1, choose 1. For the next row, you would have, whoops, 2, choose 0. Now I've got my highlighter out. Try this again. You'd have 2, choose 0, 2, choose 1, 2, choose 2. So in that combination notation, the N and R, N is your row number, and R is your place in Pascal's triangle, so the term number, first term, second term, so on and so forth. So if you look at up here, here we had term 0. So this is the 0 term. Oops, I'm on the wrong one here. Back that up a little bit. There we go. 2, choose 0. So here is row 2. Okay, and it matches up with this one. So it's the second row, the 0 term, and the first term in the row. So always count with Pascal's triangle. Remember, you always start counting with zeros in terms of row numbers or term numbers. So still in row 2, you have the first term, row 2, second term. So you can write it in that format, and you are going to see that notation. But remember that the notation that you see up here is the exact same as what you're already familiar with in terms of the previous unit. All right. So now binomial expression, expanding the binomial expression out. So from grade 10 and 11, you remember that you had to deal with the expansion, binomial expansion of x plus y squared. And for some of you, you would have seen the x plus y cubed and had to expand it out. So just as a refresher, when it's squared, you'd have to write it twice. And then some of you know it as FOIL or distributive law. Regardless which way you know it, you end up with x squared plus xy plus yx plus y squared. And those middle terms are like terms, so you have to collect them together. So you'd end up with x squared plus 2xy plus y squared. Now, the cube one just becomes a little bit more messier because it's a little bit larger. So from this, it would be x plus y multiplied by x plus y multiplied by x plus y. Now we already know, I'm going to cheat a little bit here because I just want to come up, I have to do it so you can see the pattern. We already know what x plus y times x plus y is. That comes from the previous question above. So x plus y, and you'd have your x squared plus 2xy plus y squared. Now you'd have to use distributive law since FOIL only works for two binomials. So we do the expansion, and I'm going to save ourselves a step here. I'm just going to go to final answer. So we're going to end up with x cubed plus 2x x squared y plus, and then moving on, we would end up with, and I'm just going to slide back for a second. Sorry, it'll be a 3 there, plus 3xy squared plus y cubed. And what I want to look at is the pattern that develops, or what do we notice when we're looking at that. So there's a couple of things I want to point out. So the first thing that we see in this expansion is that the x terms, so if we look here, okay, x squared starts with an x squared, ends with a y squared. Similarly, if we look at this one, starts with an x cubed, ends with a y cubed. Now, if you look at the pattern in between, the x cubed becomes an x squared. In the next term, it becomes just an x, and then it disappears. So what we find is the first term starts with the exponent n, and that's the overall exponent, so squared or cubed, and decreases to 0. Similarly, the y term then, if we look at that y term again, okay, it's not there in the first term, but in the second term we have a y, in the next term we have a y squared, and in the last term we have a y cubed. So it does the exact opposite. The last term starts with 0, and increases to n. The third thing I want you to notice from above, if we look at those terms, okay, in terms of Pascal's triangle, I'll take my highlighter out here, the coefficients, a 1, a 2, and a 1. A 1, a 3, a 3, and a 1. So 1, 2, 1, 1, 3, 3, 1. If I go back to the previous slide with my Pascal's triangle, we see that we have a 1, 2, 1, 1, 3, 3, 1. So it ends up that the coefficients are from Pascal's triangle. And finally, if we look at the exponents, we see that the 2 plus 1, the 2 on the x, the 1 on the y, they add up to 3. The 1 on the x, the 2 on the y, they add up to 3. So the exponents always add to n. And I'm going to talk about how that applies in the next video.